Okay, today we're going to be working on Course 1, Chapter 4, Lesson 4, which starts on textbook page 281. We will be multiplying mixed numbers today, so that's the heading that I'm going to get in my notebook. Chapter 4, Lesson 4, multiply mixed numbers. There's no new vocab that we have to talk about. However, we do have to remember how to convert a mixed number into an improper fraction. For example, if I have 2, so I'm going to write convert mixed number into improper. Let's say, for example, I have the fraction 2 3/4. Remember that I want to start with my denominator and multiply it times my whole number. So that's why I write the arrow in the times. Then I add my numerator. And the denominator is always going to stay the same. So in my head, if I can do this, right? If not, I have to write it down. 4 times 2 is 8, and 8 plus 3 is 11. And the denominator never changes. 11 over 4 is how you would write that as an improper fraction. We're going to be using that skill on almost every single problem today, so we have to be able to do that. Example 1. I'm asked to multiply 1/3 times 1 3/4. So first thing I'm going to do, I'm going to do that converting. 4 times 1 is 4, plus 3 is 7 over 4. So I'm going to write that there so I don't forget it. But then I'm going to rewrite my problem so it doesn't get too messy and make mistakes. 1/3 times 7 over 4. I'm looking for cross-canceling here, cross-simplifying. 7 and 3 don't have anything in common. 1 and 4 do not have anything in common. So I'm just going to multiply numerator times numerator. 7, 3 times 4, denominator times denominator is 12. 7 and 12 do not have anything in common. So for that one, I am done. Example 2. 5 1/2 times 1/3. Same thing. 2 times 5 is 10, plus 1 is 11 over 2. I'm going to sketch that there so I don't forget it, but then I'm still going to rewrite my problem. 11 over 2 times 1 over 3. Nothing with the 2 and the 1 to be canceled. Nothing with the 11 and the 3 to be canceled. I'm just going to multiply numerator times numerator, denominator times denominator. 11 times 1 is 11, and 2 times 3 is 6. Now this is an improper fraction. I cannot leave my answers improper. I need to convert this back to a mixed number. In order to do that, I'm going to do my little division problem here off to the side. The top number goes inside. The bottom number is your divisor on the outside. And I'm going to ask myself, how many times can 6 go into 11? 6 can go into 11 one time, so when I subtract, I get a leftover 5. My remainder becomes my numerator. And remember, just like before, my denominator never changes. So my answer is 1 5/6. I can check this by going back around the world. This is the saying that my teacher always taught me. 6 times 1 is 6, plus 5 is 11. 11 over 6 stays the same. Looks good. Okay, I'm going to have you do examples A and B from your textbook page 282. So pause your videos and then you can come back and get the answers. All right, 2/3 when you convert turns into 5 over 2. Now see, this one has cross canceling. Cancel, cancel, becomes ones. Oops. 1 times 5 is 5. 3 times 1 is 3. Simplify that. You get 1 2/3. Okay, for B, 3/8 times 10/3. Well, 3 and 3 cross cancel. 8 and 10 have a common factor of 2, so I'm going to divide 8 by 2. That leaves me with 4. 10 divided by 2 leaves me with a 5. And now I'm still going to multiply. 1 times 5 is 5. 4 times 1 is 4. When I convert that back, I get 1 1/4. If you got one of those wrong and you're not sure why, go ahead, circle it, highlight it, put a star next to it, ask me about it first thing in class tomorrow. Okay, now we're going to do some where both of them are mixed numbers, so this might get a little bit messy, but you'll notice I take plenty of space to do my fraction notes so I don't make any silly mistakes. There's always more paper. I can always give you more paper if you need more paper. Okay, example 3 is at the top of page 283, and I'm being asked to convert 1 7/8 times 3 1/3. I'm going to convert. Now, I'm not going to write it off to the side. I'm just going to rewrite it both times here because I have to do it, so I might as well. 8 times 1 is 8, plus 7 is 15/8. 3 times 3 is 9, plus 1 is 10/3. And then I'm going to start looking at cross-canceling, cross-simplifying. Let's see. 15 and 3 have a common factor of 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Again, I use a different color here so it stands out. 8 and 10 have a common factor of 2. 8 divided by 2 is 4. 10 divided by 2 is 5. And now I'm going to look at those numerators and denominators to multiply. I get 25/4. And 4 goes into 25. I'll do that over here. 25 divided by 4. 6 times. You get 1/4 left over. So 6 1/4 is my answer. How can I check that? Well, I can check by rounding or estimating my answer. 1 7/8 is really close to 2. 3 1/3 is really close to 3, and 2 times 3 is just 6. So 6, 6 1/4, I'm pretty stinking close. Okay, example 4 is an application problem, so I'm going to have to pick out my numbers that I need to use. It says that the Hoover Dam contains 4.5 million cubic yards of concrete. That's a lot. Okay, so we got the Hoover Dam, 4.5 million yards of concrete. The Grand Coulee Dam, so the Grand Dam in Washington contains 2 2/3 times, right, the amount of concrete. How much concrete does it contain? So I've got two numbers, really don't have any extra information. The problem even has the word times in it, so I know that this is multiplication. Once again, I'm going to convert and rewrite. 2 times 4 is 8, plus 1 is 9/2, times 3 times 2 is 6, plus 2 is 8/3. I see some common factors here. 2 and 8 have a common factor. 2 divided by 2 is 1. 8 divided by 2 is 4. 9 and 3 have a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Multiply across. I get 7. And remember, I don't get 7. I get 12. 12. Remember, it was in million cubic yards. So I'm going to write 12 million cubic yards as my answer. That doesn't look like a very good 2. All right, I'm going to go back and I'm going to check some estimation. 4 1/2, it would round up to 5. 2 2/3 would round up to 3. 5 times 3 is 15, so that's still pretty close. Close enough that, you know, it's not 5 miles away and I don't have to worry about that. All right, again, I'm going to have you pause the video, work on C, and then come back and check how well you did. Okay, remember, we're talking about a rectangular patio for C and the area of it. To find the area of a rectangle, it is length times width. I'm given 15 1/2 feet by 9 3/4 feet. Let's ballpark it first. 15 times 10, right? My answer better be somewhere close to 150 feet squared. If I don't, I did something wrong. But converting here, 15 1/2, when you convert, turns into 31 over 2. 9 3/4 when you convert is 39 over 4. No cross canceling in here, so I'm going to have to do some math off to the side. 9 times 1 is 9, 9 times 3 is 27, 0. 3 times 1 is 3, and 3 times 3 is 9. You get 9, 10, carry the 1, 10 is 12. So I get 1,209 over 2 times 4 is 8. Okay, well, I definitely can't simplify that in my head. So I'm going to go off to the side and I'm going to do my little multiplication problem. Or sorry, long division problem. 8 does not go into 1. It goes into 12 once. So I'm going to subtract. I get 4, bring down my 0. 8 goes into 40 exactly 5 times. So I'm going to subtract 40. I get 0. Bring down my 9. 8 goes into 9 one time. Subtract. I get a remainder. I don't have any other numbers to bring down. So my remainder becomes my numerator and my denominator stays the same. 151 1/8 feet squared, which if I compare that to my estimate of 150, that's really, really close. So I did a good job. Okay, for your actual assignment today, you are going to do page 285. I want you to do 1 through 6. Remember that you are going to post your answers in a document and you are going to post a picture of your work in Google Classroom. Make sure that you also bring your math notebook with your work in it to class tomorrow because we'll go over these answers and any questions that you might have.